So we're going to take some notes on, basic review stuff, labeling, what do, like, some definitions and stuff, and then we're going to dive into trigonometry. Okay, so you need some loose leaf. You also need a scientific calculator. Okay, you will need a calculator for this unit. There's no way around it. So before we start, okay, so that you're not lost, grab your calculator, and on your screen somewhere, okay, you should see, it's not doing a really good job, but you should see a D for degrees. Okay, if it's an R or rad, that's radians. You're not going to get the same answers as we will. If it's set to grad, that's gradients. It's not going to do the trick for you. So you need to somehow find a way to change it to D or DEG, right, for degrees. My calculator, I just go mode again, and there I have my three options, right, for degrees, radians, and gradients. So I would just pick the first option. Some of you have a DRG button on the calculator, so if you keep pressing it, it will just toggle between all of those options. So you got to make sure yours is set to degrees. That's all I'm going to emphasize, set to degrees. Okay, and if that is the case, you're going to be okay. You're going to be able to follow what we're doing in this unit. Okay, so that's all I'm going to say about the calculator. I don't have loose leaf with lines. I hope that doesn't throw you off. I didn't grab loose leaf when I left on Tuesday. That's when we were told. So I hope that doesn't throw you off. So I'm just using blank paper like this. Okay. So chapter 2, right angle trigonometry. And I never ended up finishing my thought on why we use that booklet as opposed to the textbook. The booklet goes through one trig ratio at a time. And we found that it wasn't very beneficial, wasn't very efficient. It's better for you to be exposed to all three trig ratios at the same time. And so this booklet is a combination of all three ratios, which you're going to learn about today. So if you're kind of unsure about what I'm talking about, don't worry about it. It's just that's the main reason why we don't use the textbook for this particular reason. For that particular reason it is. Okay, so definition, right triangle. A triangle with one right angle. That's still on there. Yeah. One right angle, and the right angle is a 90-degree angle, right? That will have a hypotenuse. That word should ring a bell. Hypotenuse across the 90-degree angle. And two legs next to the 90-degree angle. Okay, so just to give you, maybe I'll turn this light off here. Might be better. I think it's probably blinding some of you. So when we have a right angle, a right triangle, right? It doesn't matter which way it's facing, right? You have a 90-degree angle. These two lines meet at they're perpendicular to each other. And so a 90-degree angle is denoted by a box like this. And we usually have, A, B, and C. And so across from the 90, this side is referred to as the hypotenuse, which I'm sure you already know, right? The longest side is the hypotenuse. So this would be a leg, and this would also be a leg here. And this angle here is the 90-degree angle, denoted by a little box around it. Then we know it's a 90, right? So maybe let's just make an upside down triangle, make it look a little different. Here's your 90, and let's call this DEF. Okay, in that case, your hypotenuse would be here. This would be a leg, and this would also be a leg. Okay. I will also maybe just capitals, right, for notation. Capitals would be an angle, and then lowercase side length. Okay, so that's something that you need to remember. We use capital letters for angles and lowercase letters for side length, and this is the in general, right? Conventionally, if capital A is here, then we refer to the side. So this is talking about this angle, this opening here, which we will measure in degrees, right? We know that the side length of that will be across from it, which is A, right? So lowercase a will be across capital A. If this is angle C here, across from it is C like that. And across the capital B, we have lowercase b. Okay, so that's convention. That's how we label. Okay, so if capital F is here, this would be lowercase f. If capital E is here, you travel across, this is E. And if this is D, right, we call this lowercase d. So you have that here. We will change the notation a little bit later on. We'll talk about that a little later on, okay? And so we wrote down a right angle is a triangle with one right angle that will have a hypotenuse across the 90-degree angle and two legs next to the 90-degree angles, right? Continuing from this, the other two angles, right? The other two, there's a 90-degree angle and then there's two left, right? Every triangle has three angles, right? The other angles are acute, and that just means less than 90, okay? Because if you add all three angles, in any triangle, it doesn't have to be a right triangle, the sum is 180. Okay? That's always the sum of all three angles. I will sometimes just say sum of triangle is equal to 180. I will sometimes refer to that, right? So if I talk about that, I'm actually saying, remember that if you add up all three angles in a triangle, it's always 180. You can only have one right angle, okay? You can only have one right angle because if this one is 90, right? By definition, it means that these two also add up to 90 because 90 and another 90 is 180. So you cannot have more than one right angle. I hope that is clear, okay? Because that would be that would make it wrong, okay? Um, so what will I say here? Let me see in my notes here. And note, I will do a little bit more labeling. Yeah. Labeling using letters, okay? So if you have triangle X, Y, Z, let's say, right? It's like, hey, triangle X, Y, Z, how would you graph it, okay? It doesn't really matter if we're talking about a right triangle. We refer to this triangle as XYZ. So they are talking about the vertices, the corners. So we can start, because we don't know which one is the right angle, we just start here, X, Y, Z. So we use capital letters to label the angles. Therefore, this is lowercase x, just make a smaller x. This is a lowercase z, and this is a lowercase y, right? So we label, right, across the angle is the side length. So side y can also be written as side, where is y? Y is right here, is xz. So we use the capital letters like this to refer to y as side xz, right? So therefore, side z is also equal to yx or xy. Side x here would be equal to side yz or zy. It doesn't matter which order you do that in, but just keep in mind that this is still consistent. And sometimes they refer to a side length by using the two-letter notation. Sometimes they refer to the side length by just using the one-letter notation. So that shouldn't throw you off. You should still be fine with that. But that is just a side note before we continue, okay? So now I think I'm gonna go for identifying sides, right? So I'm gonna break this off here. Identifying the opposite, adjacent, and hypotenuse. This is very important for this unit, okay? These three sides will be very important to identify in this unit, in this chapter, okay? Very important. So I'll put a star like this, a star like this, right? So this sentence is very important. So let's just underline this, right? Identifying the opposite, adjacent, and hypotenuse. That's going to be extremely important to us in this unit. So let's consider triangle, right? I'm going to draw my triangle like this. Purposely making it upside down so you're not always used to it looking a certain way. So let's use letters Q, R, and S. So let's say you have this written down, and you're asked to identify the opposite, the adjacent, and the hypotenuse in this particular triangle. Okay. Well, what you need to know, the first thing is that the hypotenuse always goes across the 90. So we're going to label that hypotenuse across the right angle. Always. That's the first one that I would suggest you label. So you find the 90 degree and you go across and you label that hypotenuse. So this side length here is now referred to as the hypotenuse. Okay? And now you have to be careful. This is the right angle. There are two acute angles in this triangle. Okay? So I'm going to use a different color. I'm going to use a red pen or whatever color you have, and I'm going to say, I'm going to make an arc here referring to this angle right here. If this is your reference angle, okay? So let's say the question has it like this, has it marked like this. What you need to do is, once you've identified the hypotenuse, you move across, and the side that's across this reference angle S here would be considered opposite. So this is opposite. This is considered opposite, and this here would be adjacent. Okay? So if this is your reference angle, then this would be the opposite side to angle S, and this would be the adjacent side to angle S. And think of adjacent as, adjacent means it's touching. So the adjacent side will be touching the angle you're considering. Okay? And so maybe what I will just keep it like this for now, and we'll do another one right next to it. Okay? Right next to it, we make a copy of this. Let's make a copy of that exact triangle underneath or beside it, and we're going to still say Q, R, S. Okay? QRS, same triangle. And now I'm going to use a different color here. I'm going to use blue. Okay? Those are the only two colors that I have. And in this case, this is going to be the angle that is referenced. That's the angle. They will have to give you one of the acute angles is going to have that little arc on it, or they will say, hey, look out from this angle right here. And so from that angle there, the first side you identify before you even get started is the hypotenuse. This is the hypotenuse still. Okay? And then now that this is our reference angle, the side that is across from the reference angle is called the opposite side. So we'll put down opposite here, and we'll put down adjacent here. Okay. So, and I'll make a little note, just an arrow here. Angle S is the reference angle. And here I'll put an arrow down and saying angle R is the reference angle. Okay, so it depends. What hasn't changed? The hypotenuse stayed the same. The hypotenuse is exact same. But look at the sides. Like you had to label the three sides in both triangles. If this had been your reference angle, right? If that's the one that is marked, then that becomes the opposite. This is the adjacent. But if you're looking out from R, angle R, this is your opposite side, and this is the adjacent side. So you're like, didn't we call these two legs earlier? Yes, they're still legs, but we now have a specific name for the adjacent and a specific name for the opposite. So they change based on your reference angle, right? So I'll make a note here. Hypotenuse always stays the same. And you will say that opposite and adjacent change depending on reference angle. There's that word reference angle. Okay, it's where you refer from. It's where you go out of. Okay, and so we have that. So let's have a couple of examples here right after this, and you'll give this a try. Backside. There's some examples. So let's have them facing in an angle like that. Okay, and so we'll have A, B, C like that. We'll have one facing this way. So just copy these examples down. Okay. D, E, F. And we'll do one more. Like that. And we call that cat. Triangle cat. There you go. So copy these down, and now I'm gonna go, and this is just gonna be random, okay? I'm gonna make a label here, an arc there. I'm gonna make an arc here, and I'm gonna make an arc here. Okay. And now we're gonna label our three sides: hypotenuse, opposite, and adjacent. Right? That's the order that I would do it in. So based on this angle, hold it. Let's label our hypotenuse. Right? This is the hypotenuse. Because this is the reference angle, I travel across and I call this side the opposite side. And this must be the adjacent, right? That's why the adjacent is the easiest to label if you've done everything else correctly. Then you go here to this triangle, triangle DEF. So across the 90, that's the hypotenuse. Across this side is called the opposite. And across the D, this is the adjacent side. Okay. It all started with the hypotenuse, which is easy to find. It's the longest side always. And then you have the opposite, which is always across the given angle or the reference angle. And then the last one must be the adjacent. Last one, this is the hypotenuse. This is the opposite. And this is the adjacent. Notice that the adjacent is touching the reference angles in this case. So the hypotenuse and the adjacent touch the reference angle. Okay. That's another way of knowing whether or not you're on the right track here. Okay. Okay, so we'll go on to the trig ratios. Okay. So here is what some of you, this may ring a bell. Okay. Trig ratios. This is going to be used over and over again. In short, I use this, okay? So ka toa. Okay, SOHCAHTOA. That's what we're gonna use. And you're like, what? What is that? This is an acronym that we use to make it easier to remember the three trig ratios. Look at your calculators for 1 second. You should all have a sine, cosine, and tan button. Sin, cos, tan. And just above it, you should have a sine with a -1, cosine with a -1, tan with a -1, right? So that you should have those right above the button. Okay, so find them because they're going to be used a lot. Okay, so here we go. So if you're given a triangle, and I'm going to use ABC, but it doesn't have to be. I'm going to redo that one. That's not good. I'm going to use a ruler for that one. If I don't have lines, I'm kind of lost. So if you have triangle a right triangle like this, okay, and we're going to call this ABC. And let's say, for instance, that this is the reference angle in this case. If that is the case, then we still know that the hypotenuse is not going anywhere. This is the opposite side, and I'll put up in brackets to angle A, that is, right? This is opposite to angle A, and so this must be the adjacent to angle A. That's important to remember because if it had been here, if C was the reference, then this would have been the opposite side and this the adjacent, right? But it would be with regards to C. Okay? And here comes the if angle A is an acute angle in a right triangle, then the following is true. And this year we are going to look at oblique triangles. Oblique are the ones that are not right. We are going to do it, but we're going to use a technique. We're going to split them. We're going to cut them to create two right triangles out of them. But in grade 11, you're going to, whether it is applied or pre-cal, you're going to learn how to deal with non-right triangles. Okay, so you're going to learn that there. But this year, we can only do this. Okay, so here we go. I'm using the acronym to help me here. Sine, right, of angle A is equal to opposite over hypotenuse. Okay, this is the sine ratio. So see, I used sine of the angle as opposite side divided by the hypotenuse. So just follow me for now. And then the next one is cosine of angle A is equal to adjacent over hypotenuse. That's the second one. And the third one is tangent of angle A is equal to opposite over adjacent. Notice that tangent is the only one that doesn't have the hypotenuse in the denominator. Okay, so these are very important here. These trig ratios you want to use all the time. Okay, And so this is to help you, okay, to help you remember the trig ratios. Sorry, ratios. Okay, these are there to help you remember. That's all that they're there for. So don't use that in your calculations, okay? We use this for calculation. So this is the sine ratio. This is the cosine ratio. And this is the tangent ratio. And ratio is a comparison, okay? Ratio is a comparison. So we know that sine of that angle, whatever it's going to be in degrees, is going to be opposite side divided by the hypotenuse, okay? So just so you know. So let's do an example here. Example, determine the values for sine of A, cosine of A, and tangent of A. So now we're looking into numbers already, okay? So if you have a triangle like this, okay, you have a triangle like that, and let's call this A, B, and C. Usually we go clockwise when we label, but it doesn't really matter. It will work out regardless. So let's say this side is 26 inches and this side is 24 inches. This side here is 10 inches. So all three sides are given like that, and you asked to find sine of A, right? So we're going to start with sine of angle A. This is very important. I'm going to highlight this part. Pay close attention, okay? When you see sine of A, that is now your reference angle. Right? So you gotta, they're basically saying, right? They're basically saying that this is now your reference angle. That's where you go and make the mark on the triangle. Okay? We're considering A as the reference angle. Reference angle. Okay? So sine of A, we know based on this here, sine of angle is opposite divided by the hypotenuse in that order, no exceptions. Opposite first, hypotenuse second. And if you recall, hypotenuse is the longest side, so sine of A should have the longest side at the bottom, right? So let's label based on this. I can say that I know across the 90 this is the hypotenuse. Okay, that doesn't change. Across angle A, this is called the opposite side, and this must be the adjacent. Poor adjacent always gets left last, right? Anyways, sine of A is opposite over hypotenuse. So the opposite side in this triangle right now is 10 inches. You don't need to put the inches down because they will cancel out anyways. And the hypotenuse is 26, so you put 26 down like that. Okay, so that is it, right? And we know that this is the opposite, and that is the hypotenuse, like that. We need to reduce that. Okay, that would be equal to 2 goes in there 5 times, and it goes in there into 26 13 times, right? So if I ask to just write it, make sure you reduce. Okay, So that's what it actually is here. And then sine of B, cosine of A, my bad. I asked you to find sine of A, cosine of A, and so forth. Cosine of A is going to be, and there it is again, A is the one that we're referencing. Cosine of A is adjacent over hypotenuse. So you go and get your adjacent, that's 24, and the hypotenuse is 26. Okay. Both of them can be divided by 2, right? So 2 goes in there 12 times, 2 goes in there 13 times. Okay. Or we can divide this. Let's go ahead and do that. 12 divided by 13 is 0.923, and it keeps going, right? This is the we can have the approximate value here, right? So sometimes we want to get it as a decimal, but if I ask you to just write it, reduce the fraction, right? Tan of angle A is going to be the opposite angle. And let me say this in a different way. It's not just opposite. When you see this, you're actually saying tangent of angle A is equal to the opposite side to A over the adjacent side to A. That's what we are saying in specifically in this case, okay? So tangent of A is opposite, which is 10, and the adjacent, which is 24. 2 goes in there 5 times, 2 goes in there 12 times, right? So this is the ratio of sine of A, cosine of A, tangent of A, okay? And I will make sure I highlight that, okay? And that's how, if I ask you to determine the value or just write the values of these three, that's how you would do it, okay? And we'll practice it one more time on the back side. What's our time? Yeah, we still have enough time. So we're still catching up. I'm leaving it there for a bit. Again, I'm going to go up to the acronyms here. These are supposed to help you. If you remember SOHCAHTOA, right? SOHCAHTOA, you will remember that with sine, you have O over H. For cosine, it's adjacent over hypotenuse. For tan, we will have to take the opposite and the adjacent, right? So it basically summarizes this for you. And so you know which two sides to put where, okay? Let's do an example here to practice that. Example, write the values of the following. Okay. So I will first give you a triangle here. DEF, let's go. And we have that this is 15 feet, 12 feet, and this is 9 feet. Here you have to be careful, but I'm going to go for it anyways. So sine of E, cosine of E, tangent of E. Let's do those first. And then on this side here, I'm going to also ask you to find the sine of f, cosine of f, tan of angle f is equal to. So you are supposed to write down the numbers, basically fill in the numbers that are true for the following statements, right? And so I walk you through here. Notice that I could have mixed it up, E and F, but I just stuck with E here. Okay, so I will highlight the E's here because right now my reference angle is E. Okay, so for E, right, if this is the reference angle here, I will still call this as a hypotenuse right away. That should be the first side you identify. And now that angle E is here, I know that this is the opposite. And I know that this must be the adjacent. Okay. So what I will do is I will take my highlighter again and just say highlight these two sides based on that reference angle. You got to follow here, right? It's based on E. Opposite and adjacent are as follows. Okay. So remember, how would I know? Well, I will remember Mr. Dirksen saying so, ka, toa. Okay, that's gonna help me know which two sides I'm gonna pick. So the opposite right now is 9, right? And the hypotenuse is 15. I'm in trouble right now because I use this up, but I know 3 goes into both of them. So 3 goes in there 3 times, 3 goes in there 5 times. So this is really what it is. And this is just in brackets like that to help you, right? Cosine of E is adjacent over hypotenuse. Very important to put them in the right place. So the adjacent is 12, the hypotenuse is still 15. I'm going to erase some of this line here. And that is equal to 3 goes in there 4 times, 3 goes in there 5 times. Now I'll put this in bracket. This is just to help us remember, right? So cosine of E is 12 over 15 reduced to 4 over 5. Next is tangent, which is opposite over adjacent. So you go and say, okay, yeah, opposite is there. Adjacent is 12. I can reduce that as well. 3 goes into the first one, which is 3, and it goes on there, which is 4. Right? So you have effectively filled in and written down the values for the corresponding trig ratio. And now this might get a little tricky. I'm going to use a different color highlighter. I would strongly encourage you to do that as well, or use a different color pen to write down the following. But notice that F is here, right? This is my reference angle now. So can you in your head just forget about this? Forget about this, and now we're focusing on F as our reference angle. So I'm going to highlight F with the same highlighter I use here, right? And it can get a little tricky, but just follow me. Hypotenuse doesn't change in this triangle, it stays fixed. But based on F, if this is now my reference angle, you go out and you call this side the opposite. You're thinking, what, right? Yes, if this is the reference angle, forget about E now. Focus on F. That's the opposite, and this becomes the adjacent. And I'm going to go ahead and highlight those accordingly. I need you to, it's very important for you to understand that the opposite and the adjacent switch depending on which one of those acute angles you make your reference angle. Very important. So sine of F, it's still opposite over hypotenuse. So based on F, opposite is 12. and the hypotenuse is still 15. I'll reduce later. Cosine of f is adjacent over hypotenuse. So adjacent is 9, hypotenuse is still 12. Tangent of f is opposite over adjacent, so this is based on f. So opposite is 12, adjacent is 9. Let's reduce them. 3 goes in there 4 times, goes in there 5 times. 3 goes in there 3 times, it goes in there 4 times. Nope. I made a mistake. Nobody stopped me. Okay. Hold on. Do you see the mistake? Hypotenuse is 15, not 12. So if I was throwing you off, I apologize sincerely. I didn't mean to do that. 3 goes in there 3 times. 3 goes in there 5 times. There we go. And then 3 goes in there 4 times. 3 goes in there 3 times. Do you notice something? I don't know if you noticed, but sine of E was 3 over 5. And notice if you go over to cosine of f, the other angle, it's 3, 5. And then you have 4 over 5, 4 over 5 here. So it's almost like they flip-flopped, right? Tangent of E as your reference angle is 3 over 4. Tangent of F is 4 over 3. So those flipped, right? And so that's a neat kind of pattern that you should recognize there. Okay, so let's do some math now. This was just identifying. We'll do some math here. Example, calculate the unknown angle. And here you have to be very careful because I want you to follow the steps if you want to be all right in the next grade, okay? So let's call this A. And this particular triangle will look like this. I'll try my best to make it look nice. There we go. The right angle is there. And so we'll go with ABC again, I guess. Okay. We're going to call this 26 inches, and this will be 24 inches. And we're going to, they're indicating to us that we're solving for A like that. Right? Indicates that we are solving for angle A. And remember, don't forget, this is always going to be in the back of our heads, helping us out. So katoa. I would say write it down right away when you write your test. Write it down. Okay. Quiz, write it down. Okay, so if we're solving for angle A, we need to label. Please always label the 3 sides. It doesn't matter if you're solving for a side or an angle, label those 3 sides we just learned how to do. So based on that, across the 90, this is the hypotenuse. Across angle A, this would be the opposite, and this must be the adjacent. Okay. Now I'll tell you something. We're always labeling all 3 sides, but there's usually a do not know what it is and also don't care about it. And it's this one here. Don't know, don't care. So kind of ignore it. Just don't worry about it. Okay? And here's the kicker. Once you've determined the don't know, don't care, right? In this particular triangle, we're trying to find out what angle A is, which we will do in a bit. But you can only pick sine, cosine, or tan. You have to pick one of them, and only one of them is right. Look at what you're left. You got rid of the don't know, don't care. You have adjacent and hypotenuse left. A and H, right? Which one has A and H at the same time? Sine has O and H, right? Cosine has A and H. Bingo, right? Cosine is the one. Use to solve. Okay? Therefore, so basically we've determined the don't know, don't care. A and H is left. Use this to solve. So we actually go like this. Cosine of whatever angle they're asking me for. This could be X, Y, Z, you name it. In this case, they called it A. Cosine, sine, and tan are always glued to an angle. It could be a number or it could be a letter, but it has to have it glued to it. You can never just have cosine or sine or tan sitting on its own without an angle attached to it somehow. Remember that. So cosine of A, we know, is adjacent over hypotenuse. Okay? Start with the premise. This is what we know. Therefore, cosine of A is equal to, this is what we were just learning how to do, the adjacent, which is 24, over the hypotenuse, which is 26. Okay? So you set it up. Set up and sub in. Okay? Set up and sub in. Very important to put the values in the right place. Watch the next step. There's something we call an inverse operation. It's almost like when a number is multiplying, we divide both sides by it. This is what we do with sine, cosine, and tan. To find angle A, to have it all on its own without the cosine, we have to take what we call the inverse. It's not to the power of -1, okay? It's not that. It's just the inverse of 24 over 26. I didn't simplify because in this case, it didn't ask me to just write the values of cosine of A. It asked me to actually solve for A. So I don't really care about it. And so we're going to find out what angle A is now. Okay, are you ready? Your calculator needs to be up and going. My calculator can do this. Are you paying attention? Wake up. Okay, I need to press, I'm going to have this all up on the screen here. I need to press shift. You might have a second button or something like that, second F or shift or something. I have to press that shift button, and as soon as I press it, that little S shows up, meaning you press shift, and then you have to pick one of these, and I have to pick cosine in this case. See how that inverse cosine shows up? I have brackets, so I can go bracket 24 divided by 26, close bracket, and then hit equal, and you get an angle there. And it is 22.62 degrees. That is your answer. Always round to 2. Decimals, right? Include degree symbol. Okay, when you do inverse, you need a degree symbol because you're finding the angle. And I will tell you this. This part here must be shown. You have to, you can get away without showing this first part, like the actual trig ratio and how you set it up. And it's basically the formula. You can skip that part, but I need to see these 3 steps here. Okay, so if you want to get full marks, you have to have that there. Now, Some of you are struggling. You're like, I don't know how you got that, Mr. Dirksen. My calculator doesn't have brackets. Look up to your screen again. I'll do it one more time. If you don't have a calculator that shows you what you're typing in, doesn't have brackets, this is how you do it. 24 divided by 26 equals, okay? You leave that on your screen and then you go shift cosine equals. It will take the inverse of the decimal you have and it works the same way. Okay, so you have to figure out your calculator, how it works for you. If it's not working, let me know. I can help you. Okay, if it's not working, you got to let me know. Okay, another example, B. Let's introduce theta. There, and let's say this is 13 feet and this is 12 inches. Oh, feet, sorry, I won't do that to you. And let's say they're asking us for this angle right here. And this just means theta, Greek letter. So it's, we used A, B, and C. Now we're using theta. And yes, it's inside the triangle. That is your reference angle. Okay? So instead of the capital letters on the outside, it just looks a little different, but you still know you're supposed to solve for this guy right here. That is the reference angle. So if you want to put an arc here, you can, if it helps you out. Okay? You wrote it down, I'm assuming. Now, label. That's what first thing I do. Across this is the hypotenuse. Across from the angle that you're interested in, we call this the opposite. And this is the last poor adjacent, right? There you go. You labeled. Great. What now? Only one of the three trig ratios work, but how do I decide? Which one is the don't know, don't care here? And I hear you saying it loud and clear. It's the hypotenuse, right? Yeah, get rid of it. Don't know, don't care. You're left with opposite and adjacent. Which one has opposite and adjacent? I'll write it down one more time. You're going to dream of SOHCAHTOA. That's how often we're going to do this. Opposite adjacent. Nope. Nope. Opposite and adjacent, winner, right? Use this one. And it's determined by the two sides that are left, right? So we got to use tangent. So tan of, in this case, theta. Yep, you heard it. Remember, tan, sine, cosine, tan need to be glued to an angle. It can be a letter or a number, as you will see later. And I need to have the opposite over the adjacent. That's a fact. And here are the three steps that you need to include. Tangent of theta is equal to 13 over 12 in that order. If you go 12 over 13, it's going to be wrong. Okay? Theta, no need to put angle theta. That's the beauty of theta. It's just it's known to be the angle. We got to use this, and you have to write this in the same way I'm doing. It's not that difficult to learn. So if you want tangent to disappear, you got to take the inverse of it of the other side. Technically, we're taking it from both sides, and that's why it cancels out the tangent. But here it is. So I'm going to go shift tan 13 divided by 12. And that is 47.29 degrees. You got to round it correctly, okay? Notice a cool thing here. Note, you found that the angle, right, theta. That angle is 47.29. Let's find out what it is. Tan of 47.29. Type that into your calculator, everybody. Okay, go tan, no shift. Okay, we're not doing the inverse now. We're actually typing in tan of the angle we just found. So 47.29. That is 1.08331, and it keeps going. Okay, that's technically what you just found. You found that angle that goes in there. So tangent of that angle gives you this number. Let's go ahead and see what 13 divided by 12 is, because technically these sides are supposed to be equal to each other. Left side is equal to right side. Let's go 13 divided by 12. Wait a minute. Yeah, I know, this just blew your mind, right? It's a little different because we rounded the angle. If we used all decimals for the angle, right, left-hand side is basically equal to the right-hand side. Okay, so you've just checked whether or not that adds up. I have more examples. I'll do one more, and then you will be given some homework. Okay. See, no units. And I will ask you to solve for this guy. Okay, I'm going to pause this here. The answer is, do I? Maybe somewhere in my notes. You are correct. So let's label hypotenuse, opposite, don't know, don't care, right? That's what I'm going to start doing. So O and H, right, doesn't work. So sine of y, don't just put sine, don't just put y, okay, is going to be opposite over hypotenuse. Sine of y is going to be 17 over 21. Y is going to be sine inverse of 17 over 21. And yes, it's 5405 degrees. Bingo. Hold on. Before you go, could you find angle Z? Find angle Z. Easy way. Use sum of triangle is equal to 180. Okay? Because we know that Z is going to be 180 degrees minus the 90 you already have, minus the 54, right? The 5405 that you already have. Okay? So it's basically 90 minus 5405. I just thought I'd throw it in there. So you found Z just like that, just by using this property. Okay. I think I'm going to stop there. Yeah, I'm going to stop there. Just in your booklets, okay, it says do not write in them. You can absolutely write in them. Don't worry about it. So homework, page 1 and 2, but I will just give you a few questions. I don't want you to do all of them. So you're going to go 1 to 2, 5, and 9 for now, okay? For now, you do that. Answers at the back. The answer key is at the back of the booklet. It's handwritten, okay? So it says it at the very last page, right? It says pages 1 to 2, and there are the keys, okay? And so you just go and check there.